Hello, my name is Wajud. Today we are going to talk about measurements and units. At the end of the lesson, the student should be able to define measurements. The student should be able to list some dimensions of measurements and mention some system of units. So let's get into it. Measurement is an important aspect of physics or other sciences. It is the act of quantifying a thing or event, as physics is based on exact measurements. Now I need to drill down on this. When we talk about measurement in physics, it involves being precise when you quantify a thing or event. In physics, it's not sufficient for you to tell us that an item is heavy. You need to be precise as to mentioning how heavy it is. Is it as heavy as 20 kilograms of rice? Or is it as heavy as 25 kilograms of rice? Or is it as heavy as 50 kilograms of rice? Because the truth is that 20 kilograms, 25 kilograms, 50 kilograms are all heavy. So if you are talking about a mobile phone, for instance, and you say it is heavy, you need to specify how heavy. Is it as heavy as 25 kilograms of rice? That's not possible anyway. It could be as heavy as, is it as heavy as 2 kilograms? Or is it as heavy as 1 kilogram? Right? So when you talk about, or when you talk about height of someone, for instance, you want to specify that, okay, this person is tall. You want to say how tall. Is a person as tall as 20 meters? That's not possible anyway. Or you want to say, is a person as tall as 5 meters or 3 meters or 2 meters? Okay, so measurement involves being precise. It is the art of quantifying a thing or event in physics. Okay, so when you talk about measurements, there are some dimensions involved in measurements. First, let's talk about measurements by dimension of length. Now, when you talk about measurement by dimension of length, it includes measurement of length in one dimension, which is just how long an item is, or measurement of area. Measurement of area is actually a measurement of dimension, but that one is in 2 dimensions. Means you are talking about 2 dimensions, not just one. Or measurement of volume, which is also a measurement of length, but that is in 3 dimensions. Let's take measurement of length now. In one dimension, when you measure the length in one dimension, it means you are talking about maybe the distance between a point and another point on an item. If you look at a room, for instance, the distance from one point in the room to another point in the room, it is a measurement of length. Now, the meter rule is often used to measure the distances of a few centimeters to some meters. That is, when you talk about length, you use meter rule to measure it, because the meter rule is just a straight item used to measure length. On the meter rule, the smallest graduation is 0.1 cm or 1 millimeter. That is the smallest. If you take a meter rule, you see that it is graduated or calibrated. You see some lines on it, which is how it is calibrated or graduated. So the smallest of those lines is 1 millimeter or 0.1 cm, as you can see on the picture here. Another item for measurement of length is the vernier caliper. The vernier caliper can measure small lengths such as internal and external diameter of an object. In fact, vernier caliper is mostly used for measuring things like internal and external diameter. It means it is used for maybe round objects, so you can measure their internal diameter or external diameter. When you are measuring internal or external diameter, you are making use of meter rule. Even you yourself know that the measurement you have obtained is not accurate. What you would have measured, it will be the diameter across. It's not the actual diameter, so it's not going to be accurate. So if you want to get accurate measurements of internal or external diameter, the equipment to use is the vernier caliper. Now, on the vernier caliper, the smallest graduation there is 0.01 cm or 0.1 mm. So the smallest graduation on a vernier caliper is 1/10 of the smallest on a meter rule, and that means that the vernier caliper is more accurate because it can measure smaller quantities compared to that the meter rule can measure. Then another item that is commonly used for measuring even smaller measurement of length is the micrometer screw gauge. The micrometer screw gauge measures even smaller lengths, such as the diameter of a wire. So the micrometer screw gauge can measure diameters or lengths that are smaller. Just like the vernier caliper can measure smaller than meter rule, the micrometer screw gauge can measure even smaller quantities compared to that of the vernier caliper. The smallest graduation on the micrometer screw gauge is 0.01 millimeter or 0.001 cm. So that means that the smallest graduation on the micrometer screw gauge is 1/10 of the smallest on the vernier caliper. So when we talk about measurement of length in 2 dimensions, that is measurement of area. The area of an object depends on the shape of the object. Now remember I said that measurement of area is in 2 dimensions. It means if you are measuring the area of a room, you are going to be taking maybe length and then another measurement that is also a length, maybe length and breadth, okay, or maybe length and height, depending on what you are measuring, if it is the length of a floor or length of a wall, okay. So it could be length and breadth or length and height. So the point is just that to get the measurement of an area, you need 2 dimensions of length. Then when you talk about measurement of volume, we said that is 3-dimensional, right? So you use apparatus like measuring cylinder, pipette, conical flask, beaker. Equipment like that are used to measure the volume of a substance, right? And remember, volume is a 3-dimensional measurement of length. Another dimension of measurement apart from this of length, which we have just mentioned, is measurement by mass and weight. Mass is a measure of the quantity of matter contained. Mass tells us the amount of matter that is present in a body. Weight, on the other hand, is the force acting on the body due to the Earth's gravitational pull. Please note that weight is a force, okay? It is a force acting on the body due to the Earth's gravitational pull. While mass, on the other hand, is a measure of the quantity of matter contained in a body. So weight is directly related to mass as given by this equation, that weight is equal to the mass multiplied by the acceleration due to gravity. The acceleration due to gravity is a constant depending on the point you are on the surface on the Earth. The value ranges from 9.8 meter per second squared to 10 meter per second squared. Example of instruments used in measuring mass and weight are: mass is measured using beam or chemical balance. Beam or chemical balance is actually common in laboratories, in school laboratories. Lever balance is also used to measure mass, and a dial spring is also used to measure mass. For weight, equipment like spring balance, digital scale, precision balance, and weighing balance are used to measure weight. Now, because people usually confuse mass and weight, it is important for us to distinguish between them. And what is the difference? What are the differences between mass and weight? First, mass is constant, while weight varies. No start. Mass is the quantity of matter contained in a body, so it is constant. It does not change. It is just the quantity of matter contained in a body. It is constant. Weight, on the other hand, is mass multiplied by the acceleration due to gravity. Like I said, depending on the point you are on the surface of the Earth, the acceleration due to gravity can vary from 9.8 meter per second squared to 10 meter per second squared. And that means the weight can also vary because the weight depends on the mass and the acceleration due to gravity. Mass unit is kilogram, while the unit of weight is Newton. That is, the unit of measurement of mass is kilogram. So when you measure mass, you can say the mass is 1 kilogram, 2 kilogram, 3 kilogram, like that. But when you measure weight, the value is going to be like 10 Newton, 15 Newton, 20 Newton, like that. Mass is a scalar quantity, while weight is a vector quantity. That is, scalar quantities do not have direction related to them. Okay, so mass is just a scalar quantity. There's no direction involved when you talk about mass. But weight, on the other hand, is a vector quantity. In fact, I can tell you that the direction of weight is always vertically downward, because it is the force with which the Earth pulls an object towards its center. So it's always vertically downward. Now, another dimension of measurement is time. Time distinguishes an event from another event. That is, time is a quantity used to distinguish between events with reference to before and after. If an event occurs at 2 a.m. and another occurs at 4 a.m., then you know that the one that occurred at 2 a.m. occurred before, while that occurred at 4 a.m. occurred after. So time is used to distinguish between events. Example of some equipment used to measure time are stopwatch, clock, hourglass, and digital watches. I believe you are familiar with most of these: stopwatch, clock, hourglass, and digital watches. So now let's talk about physical quantities. When we say quantity in science or in physics, it is a measurable property of an object. A quantity is a property of an object that can be measured. For example, when we talk about property of objects, an object can be heavy, okay? So when you see something is heavy, we can measure it. We can say it is 2 kilogram heavy, it is 3 kilogram heavy, it is 4 kilogram heavy. So that means that the mass of an object is a quantity because it can be measured, right? If you say that an item is tall, we can measure the height to know precisely how tall it is. Is it 2 meters tall? Is it 3 meters tall? Is it 4 meters tall? So because we can measure that particular quantity, that particular property, it means that property is a quantity. But if we talk about the color, okay, of an item, it can be yellow, it can be green, it can be blue, but you can't really measure how yellow it is, right? If it is yellow, it is yellow. You can't say it is yellow by unit of 2 or yellow by unit of 3. Yellow is just yellow, right? So that is not a quantity. It is a property of the object, but it is not a quantity. So in science, quantities could be fundamental quantities or derived. Fundamental quantities are fundamental. They are quantities that do not depend on other quantities, and they are also called basic quantities, right? Fundamental quantities are independent of other quantities. They are like self-reliant. They do not depend on other quantities. Derived quantities, on the other hand, are quantities that depend on other quantities for their derivation. For example, when we talked about weight at that time, we said weight is mass multiplied by the acceleration due to gravity, that it depends on both the mass and acceleration due to gravity, right? So weight is an example of a derived quantities. And following quantities is units. Units tell us what quantity is being measured. For example, if I say 2 seconds, you know that is time. If I say 2 hours, that is time. If I say 2 kilograms, that is mass, right? If I say 2 meters, that is length. So unit is just a way of letting us know what quantity is being measured. Units can also be fundamental or derived. Fundamental units do not depend on other units, just like fundamental quantities do not depend on other quantities. And fundamental units are also called basic units. Derived units, on the other hand, depend on other units for their derivation. Now, there are different systems of units in science, right? One is the foot pound second system, which is the FPS system. This is also called the British system. It is based on measuring length in foot. I've said that you can measure length in 2 meters, 3 meters, right? But in the FPS system, the foot pound second system, length is measured in foot, mass is measured in pound, and time is measured in second. Another system of measurement unit is this CGS, the centimeter gram second system, which is also called the CGS system. It is based on measuring distance in centimeter or measuring length in centimeter, measuring mass in gram, and measuring time in second. The third system of units is the meter kilogram second, the MKS system, which is also known as the standard international unit system. It is the generally accepted system of units. Now, dimension. Dimension is the power to which fundamental units of mass, length, and time are raised to express physical quantities. Now, there are many quantities in science, right? Now, what dimension helps us do is it helps us to know how do these quantities depend on mass, length, and time. How does weight, for example, how does it depend on mass, length, and time? How does speed? How does it depend on mass, length, and time? And by the way, a quantity does not have to depend on the 3 of them. Maybe it just depends on 1, or it depends on 2, or sometimes the 3. So dimension tells us the power of mass, length, and time, which a physical quantity depend on. Dimension formula usually look like m raised to power a, l raised to power b, t raised to power c. M, L, and T are the dimensions of mass, length, and time respectively, while A, B, and C are the powers of those dimensions to which the physical quantity being described depends on. So the table here shows us the dimensions of some physical quantities, that is how they depend on mass, length, and time. So we are going to continue from here in our next class. Thank you very much for listening.